मॉर्निंग स्टूडेंट्स। आज हम नेक्स्ट टॉपिक लेते हैं। वी कंसीडर न्यू टॉपिक इलेक्ट्रिक फील्ड ड्यू टू यूनिफॉर्मली चार्ज नॉन कंडक्टिंग solid sphere. We have a solid sphere of radius r. In this topic we have three cases. First case, outside the solid sphere, and second case on the surface, and third case inner side of the sphere. So we have a solid sphere which is uniformly charged. This is solid sphere. Uniformly charged by charge q. This charge q, this charge q is distributed in this volume of solid sphere. Uniformly distributed in this volume of the solid sphere, and the radius is r. Solid sphere is have radius r. The point P is outside of the sphere. At the point P, we have to find electric field. So we consider a Gaussian spherical surface of radius small r. This is the first case. Our outside the sphere, where small r is greater than capital R. R is the radius of solid sphere. Capital R is the radius of solid sphere. So this is the Gaussian spherical surface. We consider a surface element which have ds vector in the electric field direction. Electric field direction is in the radii. मतलब इलेक्ट्रिक फील्ड की जो डायरेक्शन है वो त्रिज्या की दिशा में है. सो एंगल बिटवीन E and ds, electric field and area vector, theta is 0 degree. Then from Gauss law on the closed loop integration, electric field dot ds is equal to sigma q upon epsilon naught. E is the electric field dot, so angle between the electric field and surface element, yeah, area vector ds. Sigma q is the charge in the sphere. Gaussian surface के अंदर जितना चार्ज है वो सिग्मा क्यू है. एप्सिलॉन नॉट इज द permittivity of the free space. Now here sigma q is equal to capital Q. We see that Q is the charge which is in the Gaussian spherical surface. So sigma q is equal to capital Q. Now EDS, angle between EDS, electric field, and area vector, which is 0. So E ds. This is dot product. Then cos 0 q upon epsilon naught. Cos 0 is equal to 1. Electric field on the circumference of the Gaussian surface is uniform. Then electric field out of the इंटीग्रल, इसे इलेक्ट्रिक फील्ड E है तो इस इंटीग्रल के बाहर आ जाएगा. Then is equal to q upon epsilon 0. This is the surface area of the Gaussian surface, which have radius of small r. Then surface area is 4 pi small r square q upon epsilon 0. Now the equation is E equal to 1 upon 4 pi epsilon 0 q upon r square. This is the formula of electric field outside the non-conducting solid sphere. In vector form, 1 upon 4 pi epsilon 0 q upon r square r k. This is the vector form. Here we consider a step which is volume charge density. Volume charge density rho is equal to charge upon volume q upon 4 upon 3 pi r cube. Here q upon 4 pi. So we take value q upon 4 pi is equal to rho r cube upon 3. Now this formula is electric field is equal to rho r cube f3 epsilon naught r square r cube. This is the electric field in form of volume charge density. ये फार्मूला भी आप याद रखना. ये फार्मूला वॉल्यूम चार्ज डेंसिटी के रूप में है. ये डायरेक्ट फार्मूला है आउटसाइड द स्फीयर फॉर सॉलिड स्फीयर यूनिफॉर्मली चार्ज्ड. Now we consider second case. On the surface. We know that three cases here. First is outside the sphere, second is on the surface, and third is inner the surface. Now we consider on the surface. The P point is on the surface. P have distance from center is r, because this is radius of solid sphere. Q charge is uniformly distributed in the volume of solid sphere. Now small r is equal to capital R. Then electric field is 1 upon 4 pi epsilon naught q upon r is capital R, then r square, in the form of vector 1 upon 4 pi epsilon 0 q upon r square r cap. This is the form of form of this formula. On the surface of non-conducting uniformly charged solid sphere. Now in the form of volume charge density. Volume charge density क्या होती है? Q upon 4 upon 3 pi r cube. We take the value 4 pi r square, then rho upon 3 r. This is right. Q upon 4 pi r square की वैल्यू रख दो. Then electric field is rho r upon 3 epsilon 0 r cap. This is the formula of electric field in the vector form in the volume charge density. This formula written as this type is E equal to rho r upon 3 epsilon 0. This is a simple form of the electric field on the surface. If any question there are given volume charge density, radius of the sphere, epsilon naught is, remember that 8.85 into 10 to the power minus 12 SI unit. Then we put the values and get electric field. Now we consider third case. This is very important. Inner side of the solid sphere. We know solid sphere is uniformly charged by Q charge. Third case. Inner side the sphere. This is our solid sphere, uniformly charged by Q. This is the center O. This is the radius of solid sphere. This is the point P where we conclude the electric field. P have the distance from center O is small r, where small r is less than from capital R. We consider a Gaussian surface, spherical Gaussian sphere of radius small r. We consider a surface element ds which have area vector ds in this direction and electric field V also in this direction. Then theta is 0. This is angle between area vector and electric field. We know all the points, same previous topic. Now Gauss law. E dot ds equal to sigma q upon epsilon 0. The angle between electric field vector and area vector is 0, then cos 0 is 1. E is uniformly distributed on the Gaussian surface, so E इंटीग्रेशन के बाहर आ जाएगा. ds equal to sigma q is equal to q dash. If q dash is in the Gaussian surface total charge, we assume q dash epsilon 0. Then surface area of Gaussian surface is E equal to 4 pi r square q dash upon epsilon 0. Now equation is 1 upon 4 pi epsilon 0 q dash upon r square. This is equation number 1. Now we conclude the value of q dash. Then our problem is solved. Rho is the volume charge density, charge, total charge and upon total volume. This is the charge per unit volume. Then charge on the Gaussian surface, q dash is equal to rho into the volume of Gaussian sphere. Now rho into 4 upon 3 pi r cube. We put the value of rho, q upon 4 upon 3 pi r cube in times 4 upon 3 pi r cube. Then 4 upon 3 pi, 4 upon 3 pi is cancelled. Then qr cube upon r cube, q dash is equal to qr cube upon r cube. We understood each point of this topic. Now this is equation 2. From equation 1 and 2, E equal to 1 upon 4 pi epsilon 0, q dash is 1 upon r square, q dash is q upon r cube upon capital R cube. Then r, E equal to 1 upon 4 pi epsilon 0 q r upon r cube. Now k q r upon r cube. Vector form k q r cap upon r cube. This is the vector form of the formula. Inner side of the solid sphere. Now volume charge density in the form of volume charge density. We take this formula in easy form. One upon 4 pi epsilon 0 q r cap upon r cube, rho equal to q upon 4 upon 3 pi r cube. Now q upon 4 pi r cube is equal to rho upon 3 q upon 4 pi r cube. Then electric field vector is equal to rho upon 3 epsilon 0 r cap. Now in the simple form, E equal to rho r upon 3 epsilon 0. This is the simple form of the electric field. This is the vector form. ऐसे भी लिख सकते हैं और this is the vector form, right? E rho r cap upon 3 epsilon 0. This is the formula. We have to remember this formula. This is the inner side sphere electric field due to uniformly charged solid sphere. Now we consider a numerical. पहले हम बोर्ड को अच्छी तरह से साफ कर लेते हैं. In this numerical, we have 3 solid spheres which have different radius and different charge on it. We call these sphere dielectric sphere. ठीक है ना? ये या तो डायलेक्ट्रिक स्फीयर बोल सकते हैं या फिर नॉन कंडक्टिंग स्फीयर, सॉलिड स्फीयर. नाउ इन न्यूमेरिकल, this is the solid sphere, center O, radius r upon 2, charge is q, and point P, कैपिटल R डिस्टेंस पे पॉइंट P है. इस पर हमें इलेक्ट्रिक फील्ड ज्ञात करना है आउटसाइड द स्फीयर. And second, center O, radius R, point P on the surface, point E in every case. In each case, the distance of point P from center is capital R. Charge on it 2q. This is second sphere, this is first sphere, this is second solid sphere, third sphere, the radius is 2r. Uniformly charged, 4q charge, and point is r डिस्टेंस पे p. इसमें इलेक्ट्रिक फील्ड ज्ञात करना है. नाउ फ्रॉम द फॉर्मूलाज, आउटसाइड द स्फीयर इलेक्ट्रिक फील्ड इज 1 upon 4 pi epsilon naught q upon r स्क्वायर होता है ना. तो चार्ज है q और डिस्टेंस है इस कैपिटल R. ये तो होगा E1. E2 ऑन द सरफेस, सेकेंड केस, 1 upon 4 pi epsilon 0. चार्ज इज 2q upon distance is, radius is r square, radius of the solid sphere. Now this equation is 2 into 1 upon 4 pi epsilon 0 q upon r square. E3 inner side the solid sphere. Now 1 upon 4 pi epsilon 0, charge is 4q, point distance from the center is r, and radius is r cube. Radius is 2r cube, right? Then 4qr upon 4 pi epsilon 0 8r cube. Now the final E3, 1 upon 4 pi epsilon 0 q upon r square times 1 upon 2. Now हम देख सकते हैं कौन ज्यादा है कौन कम है. सबसे जो ज्यादा है वो E2 है, उसके बाद E1 then E3. This relation in between E2, E1, E3 is right. इसको अपने ऐसे भी लिख सकते हैं, E3 सबसे कम, फिर E1 सबसे ज्यादा, E2. This option is right. Thank you for watching and giving your valuable time. I hope that you have understood all of my points of lecture. If you have any questions and suggestions, then comment on this video. We will try to improve it, and we will keep in mind your concern and try to improve it. Thank you very much.